Okay, then let's go ahead. The next topic, intrinsic distance. Before we talk about intrinsic distance, we can see what is a intrinsic, the term intrinsic, and what is an intrinsic geometry. Roughly speaking, intrinsic geometry is described by first fundamental form. What is first fundamental form? When you think about the Riemannian manifold, that is defined by Gij, but instead of Riemannian surface, that is two-dimensional. So I and J is only 1 and 2. Okay? So we can think about instead of EI, EJ, think about two direction of vector XU, XV. If you think about the torus is given, that part is XU, that is XV. The two direction of the differentiable vector. Okay? And when you think about this here, we can define XU and XU is just to use a inner product notation, that is E. And in a similar fashion, in a similar way, you can define XU and XV is that is equal, that is F, and XV and XV is equal to G. So EFG we call the first fundamental form. And based on EFG, we can think about many defined geometrical properties of geometrical definition. For example, we can define Gaussian curvature is defined by K, is denoted by like this, that contains a first fundamental form. So Gaussian curvature is a property that has an intrinsic geometry, and where L is defined by LMN, okay. Like this. So, for example, furthermore, when you think about intrinsic geometry, the most important aspect is preservation by mapping, which property is preserved by which map preserved the information about intrinsic geometry. For example, we can think about a plane R2. If we identify each edges like this, mathematically that is described by G square. That is homeomorphic to torus. That name is flat torus, as you see. Think about the map for F, and when we investigate a curvature that is plane, the Gaussian curvature is 0. But in case of flat torus, so the curvature is also 0. Note that unlike a torus that obtained by surface of revolution, that has not zero torus in everywhere. That torus has different sign where the point is. For example, that point is curvature is 0. Inside is negative curvature. That part is positive curvature. But in case of flat torus, that is always 0 curvature, and that preserved that property, 0 curvature, is preserved by the given mapping F. So the main point of the intrinsic geometry is which map preserved the information of intrinsic geometry information. Apart from the Gaussian curvature, there are many geometric information that based on the intrinsic geometry. For example, intrinsic distance, as I will introduce, or geodesic, and so on. Many information about intrinsic geometry. Okay. Then, what is a intrinsic geometry? Intrinsic distance. Our main topic is intrinsic distance. So, let M be a Riemannian manifold and consider an arc length as I defined when I explained the Riemannian manifold. Okay. Now, take a point P and Q in M. Just to change the point P and Q, then an intrinsic distance denoted by PQ, low PQ is the infimum. Every arc length between from P to Q is given. We can find the infimum of an arc length. Okay, so for example, if you think about nice. Manifold M and consider 2 points PQ. We can find there are many paths along the from P to Q, okay? But the infimum, if that is the infimum, that is intrinsic distance. Along many curves connected from P to Q, the minimum, we can find the shortest path if you fix the 2 points P and Q. So that is related to length minimizing curve. More fancily, that is find the optimal transport between 2 points. If you have a truck and you a parcel from P to Q, you will find the shortest path. By doing so, we can save time and energy. Okay, so that is fine to optimal transport problem. That is important. The lecture 8, section 8, to define a P-Wasserstein metric. So because that part of differential geometry is important to anyway, that is the shortest path to here. The red curve, then red curve. But because that has a torus, so without a bridge, we can transport P to Q like this way. But this is written as the norm PQ. So remark is that intrinsic distance, when you compare to this the distance length from PQ, that is always greater or equal than intrinsic distance is always equal to greater than the length from P to Q.